Okay, here we go. The desire is to be able to measure the speed of a model powered motorboat rotating round a lake at 104 miles an hour. The speed is measured by either 52 pulses detected by this opto coupler there, or 25 pulses. The 25 pulses will arrive in this little RF receiver, 318 megahertz, and be fed into the Arduino NANO. And with exactly 52 hertz, we have a speed of 104 miles an hour, which is the exact desired time that the boat should rotate round the lake in. Now what I have here is the basic setup with the Arduino UNO with 9 volts in. I'm using the Arduino UNO regulator to power the RF receiver and also the display. The display is an IC² OLED, and that's about the basic setup. I think it's fairly plain. Now, looking at the code, what we're looking at here is the interrupts piece of code, which I'm afraid I have no idea what I'm doing with at all. So here's the code. I will actually have the code, put the whole code as is in an email for you. Now the problem we have is twofold. One, it only increments in steps of 3, and you can see that those steps are 3, 94, 97, 101 and 104, and of course we can go higher. But the other problem is, and I'm just adjusting the square wave out of this little mock-up here just to get the thing going, and we can see that on the scope, which is 52 hertz. Now anyway, back to this thing. If I reduce the speed of the motorboat, we go down in increments of 3, as I've said, and the last problem is that it will not measure below 63 miles an hour, no matter how low I turn it. Even if I turn it down to like very slow, it's still chucking up 63 miles an hour. So that's the desired effect. That's the problem. What we actually want is for this to measure in increments of 1 mile an hour rather than 3 miles an hour, and for it not to pack up at anything below 63 miles an hour. So there's the actual desire, and there's the problem, and all we want now is a solution. Thank you.